A box plot is a visual way to look at the 5-number summary that also shows potential outliers. So it is a great graphical tool for visualizing a distribution, but it's only really good for unimodal distributions. They are really nice to compare 2 or more distributions together. You can make side-by-side box plots and really compare then visually, like which one has the higher median, which one has more spread, things like that. So to actually create a box plot, or what it's created from, is that there is a box with the left edge at Q1, the right edge at Q3, so that the whole box represents the IQR. There's a vertical line somewhere inside that box that represents the median. And if the median line is mostly centered inside the box, this indicates that the data is fairly symmetric. Then there are horizontal lines called whiskers. So you might sometimes hear this called a box and whisker plot. These whiskers extend from the ends of the box to the minimum and the maximum values. They're relatively easy to draw by hand as long as you already know what the quartiles are. So how do they help us to see outliers? Potential outliers that can be seen in a box plot or that you can just kind of calculate and look at are values that are less than 1.5 IQRs below Q1 or more than 1.5 IQRs above Q3. So they are calculated with the formulas Q1 minus 1.5 IQRs and Q3 plus 1.5 IQRs. And that might seem a little weird right now, but when I show you the calculation in just a second, I think you'll see it's not all that difficult. Box plots, or not necessarily box plots. You can use a box plot for any kind of data, and looking at the box plot can actually tell you whether it is symmetric or skewed. But as far as figuring out whether these are potential outliers, these formulas are mostly used if you're talking about skewed data. There's another way to talk about outliers if your data is symmetric. So mostly these formulas are used when you have skewed data, again, for the most part. Box plots can either be drawn horizontal or vertical, and the direction is not really important. I like to draw mine horizontally just because that to me is a little bit more visually pleasing and readable, but a lot of programs create them vertically and it really doesn't matter. You get the same information from them. Okay, so we have, for our example, a dot plot here showing the distribution of passing rates for the bar exam at 185 law schools in the US. And we have the 5-number summary. So they have already told us that the minimum value is 26, that Q1 is 80, that median or Q2 is 86, that 90 is Q3, and that the maximum value is 100. And we could calculate those if we wanted to by using technology or by actually having the data in front of us. But we don't have these 185 scores, so we just have their summary. And that's really what we need in order to draw this box plot. So we're going to draw a box plot and determine if there are any potential outliers. To draw the box plot, I have to draw it extending from Q1 to Q3, so a helpful bit is to know what is the IQR. So again, the IQR is to take Q3 minus Q1. In this case, that's 90 minus 80, which is 10. So the IQR is 10. Why I need that is to figure out if there are any potential outliers. So to see, are there possibly any lower outliers? And again, I'm looking at this distribution right here. And just by looking at it, I'm thinking, yeah, maybe there looks like there's definitely one outlier. Are any of these also possibly outliers? I'm not sure. So let's do this calculation to see, like, where is the cutoff for being called a potential outlier? So I'm going to take Q1, which is 80, minus 1.5 IQRs. IQR is 10. So I'm taking 80 minus, and 1.5 times 10 is 15. So we get 65. So any values lower than 65 are potential outliers. So let's see, 65 would be about right. This would be about 70. So 65 is about right here. That means that everything out here are potential outliers. So I've really felt that this low 26 was, but I wasn't sure about some of these others. And this says that anything below that 65 mark, but remember, it's a potential outlier. Maybe it is, maybe it isn't, but that's sort of the cutoff line for calling it one. The upper limit, let's see, the upper limit is Q3, which is 90, plus 1.5 IQRs, which is 10. So 90 plus 15 is 105. So up here, sorry, I guess I need to go back. Are there outliers in the lower? Yes. Definitely in that lower area, there are some outliers. In the top, so it would be any value over 105. But we already know the max value is 100. That's the max value. Then there are no values beyond 105. There's nothing over here. So no, there aren't any outliers in that upper direction. Okay, if we want to draw the box plot for this, the box itself is drawn from Q1 to Q3. So that will be from 80 to 90. So 80 is right here. I'm going to draw the left edge of my box. Then there's 90 right here. So this is the box. The median goes inside that box somewhere. It's another vertical line. So this one is at 86. So just very ever so slightly off to the right, almost completely in the center. And then your whiskers go out to your min and your max. So my whisker in the right hand goes to 100. And into the left-hand direction, oops, not quite that far, goes to 26, so about right here. And so what you can sort of see is I can see that there is some kind of skew or some kind of outliers going on in that left-hand direction, since that left-hand whisker is so much longer than the right-hand one. The median, though, is pretty much centered inside that box, and that kind of shows that the rest of the data, though, like other than these outliers, the rest of this is fairly symmetrical. So I can get all that information simply by looking at the box plot. Even if I don't have all of the data and every single data point in front of me, I can still get the idea of skewedness, of potential outliers, and of any kind of symmetry.